This is the textbook notes lecture on Chapter 17, the Atmosphere, Air Quality, and Pollution Control. It opens up with a case study about the air in LA and Mexico City. Los Angeles is one of the major cities in the United States that is known to have extremely poor air quality. So we will be talking a lot about LA and California in general. They have a major smog problem in LA and also even in Mexico City. So just read over that because you might reference LA and California on the AP exam. All right. So the first thing we're going to talk about is the atmosphere itself. Big thing that you need to know is the percents of gases. So what's the largest and second largest of concentration? So nitrogen, which is N2, your diatomic, 78%, oxygen is 21%, and all other gases are roughly 1% of all the atmosphere. Nitrogen is less dense than your oxygen, so that's why it rises to the upper atmosphere. And that's why, for the most part, we only find oxygen in the troposphere. Okay. And then as you can see here, in your diagram, it breaks it up for you. All the different gases. All right. Now, in your textbook, they forget one layer. So you have your troposphere, your stratosphere, your mesosphere, your thermosphere, and then there's also the exosphere, which they don't mention. This is the outermost layer, and it has the lowest atmospheric pressure. That's basically all that you need to make sure you know is that the outermost layer. Now, the troposphere, this is where we live, okay? This is where humans, for the most part, function. This is the layer that we care the most about. This is where majority of your air particles are, most of the mass. It's the highest density. This is where all weather occurs. This is also where global warming occurs. All right? Now, when you go up to the stratosphere contains the ozone layer. All right? And why the ozone layer is so important is that it protects us from UV radiation. All right? If we didn't have the ozone layer, we'd all burn basically to a crisp. Ozone is as O3. All right, it's good in the stratosphere. It is bad in the troposphere. It's actually considered a pollutant if you find ozone in the troposphere. So make sure that you know the difference between those and know all the 5 layers in order. Okay. Some vocabulary that you need to make sure that you know: atmospheric pressure, relative humidity, convection circulation, and weather versus climate. Probably weather versus climate is the most important. Remember, weather is day to day, whereas climate is over a long period of time. Weather is what you check when you want to know what to wear for the day. Climate is what you check when you're trying to book a vacation and you want to make sure that it has the weather that you want when you go on vacation. Now, one word your textbook doesn't talk about is microclimates. And this is a local atmospheric zone where the climate differs from the surrounding area. It can be extremely small, like a garden plot or bricks on a house, where that's a warmer area, to a few square miles. Now, San Francisco, everyone assumes California associates it as like a warm area. However, San Francisco is much colder than all the surrounding areas. So San Francisco is actually on a bay, and ironically, it's a good 10, 15, sometimes even 20 degrees colder than areas that are literally on the bay as well. So it's just one of these random microclimates that are much different. Now, the next thing you need to know is this lovely little diagram down here. And this is all talking about the curvature of the Earth and why certain areas are heated more. And it's all about the angle in which the sun penetrates the Earth's surface. So the equator, the sun is always directly overhead the equator, and this is why that area is always warmer. As you look here, it has the most direct sunlight at all times. Whereas your poles, they do not. They have a low angle of incoming sunlight. So both up here and down here. So if you look at the polar regions, they have less sunlight per surface area. So just make sure you understand that. All right. The other 2 big figures on the next page you need to know. The first one is seasons. All right. Seasons are caused by the tilt of the Earth's axis. It's not when the sun is closer to the Earth and when it's farther away from the Earth. It's all about the tilt, which is 23.5 degrees, as well as the rotation of the Earth. All right. So when you look at this, make sure that you know that. Also know that the seasons are opposites for the northern and southern hemispheres. So when it's the northern hemisphere's summer, it is the southern hemisphere's winter, and vice versa. So make sure that you know the difference between those. Convection cells. Now, we have these in both air, we have these in water. It also happens on land itself. The magma that's underneath our plates in the center of the Earth actually moves these plate tectonics. And so make sure you understand that as you have warm air, okay, hot air rises, then it expands when it cools, then it creates your clouds, and then eventually cools down, and then cold air sinks, and then the cycle continues over and over again. So it makes this almost like conveyor belt type of system. Now, high pressure systems, which is related to fair weather, that's usually you're clear and sunny. A low pressure system is usually when you get a lot of precipitation. So this is when you get your major rain or a snowstorm. Okay. The next big thing you need to know about are thermal inversions. This is when a warm band of air becomes between two cold air masses. All right, and your textbook doesn't really show this that well. So basically, when this happens, this is what traps air pollution in our lower atmosphere, and it tends to happen near coasts more often because an ocean breeze can blow cool air under the warm air. So make sure you just look at these diagrams here. So under normal conditions, the surface is warmer than up there. And then as you can see here, what happens, and then it mixes. Under a temperature inversion, for some reason, it's cooler on below the Earth and warmer on top. And then that's what causes the pollution to get trapped. Okay. Thermal inversions also happen in cities near mountains, where the mountains cast a shadow and cool the city in late afternoons. And the lower air mass cools while the sun is still warming the upper air mass. So that's when you can have this occur. So major cities near mountains. All right. The next thing you need to make sure you know about is the Coriolis effect. This is the rise of warm air and fall of cool air at every 30 degrees latitude. And you also need to make sure you know a convection cell and the spin of the Earth on its axis. These all create wind. Okay. Now, if you look at this diagram down here, notice you have all these cycles going on, but they're going in opposite directions, and they're broken up by every 30 degrees. Okay. Deserts and arid climates occur at 30 degrees north and south latitudes. All right. And near the poles. At 90, which are not labeled on your, on your graphs. All right, whereas at the equator, which is where the doldrums are, notice it says it's wet and tropical. So at the equator and also at 60 degrees, they're going to be mostly wet or moist or tropical weather. So make sure that you know those latitudes, which ones are usually dry, which ones are usually cold. Now, the Hadley cell, this is when cool air is dropped, and that's why it's dry. So if you look in the diagram at the Hadley cell, notice cool air is dropping onto the landmass, so that's why it is dry. In Canada, go up here at the 60 degrees, notice that you have, it's going the opposite way, and you have some warm air that's dropping. So just keep that all in mind. So just make sure you have an idea how all this stuff works. All right. Your text then goes into some of your storm hazards. Make sure you understand what a hurricane is. And hurricanes actually have multiple names. A cyclone, which happens usually in the southern hemisphere, and typhoons, this is what we call a hurricane in the Pacific Northwest. Tornadoes, and then ambient air pollution. So those are some vocab words that you need to know. On the next page, this figure talks about all your natural air pollution. So make sure you know these three examples. We get natural air pollution from forest fires, from volcanic eruptions, as well as dust storms that blow from your desert location, so like from Africa to the Americas. So these are all examples of natural air pollution. Just like water pollution, we have point and non-point sources. Point sources of air pollutions are your factories, specifically, and as well as power plant smokestacks. So again, we can literally point at them and say this is where all the air pollutants are coming from. Non-point sources are our cars. We can't pinpoint one exactly. So traffic and car use, buses in general are all non-point sources of air pollutants, as well as fireplaces and other things like that. Make sure you review primary and secondary air pollutants and you know which ones are which. Okay. The Clean Air Act. So we've talked about this before when we did our legislations earlier, but there's some provisions. So the Clean Air Act basically created standards for air quality. So we decided this is the max it should be. This is considered clean air. This is considered not clean air. They also set emission limits for industry and transportation. So they started mandating that certain factories or that your cars or your buses, they were only allowed to emit certain amounts of pollutants. They also find money for research for pollution, and it allows citizens to actually sue violating parties. So if you live next to a power plant that you think is polluting too much, you actually can sue them because they're endangering your well-being. And also, the cap and trade pollution permits comes under play from the Clean Air Act. Now, the EPA came up with 6 criteria pollutants. That is your carbon monoxide, your sulfur dioxide, your nitrous oxides or NOx, your VOCs, or sometimes people call them VOCs, your particulate matter, and lead. So these are the 6 primary criteria pollutants. Make sure you know them in all their details. Review the chart that we made in class. Okay. Now, the Clean Air Act is actually one of the few legislatives that have been very productive. It has helped decrease the levels and improve our health in terms of air pollutants if you look at the data over here. And however, even though we have managed to decrease the amount of emissions we emit, we still use a lot more energy than we historically have. The population still is growing, we still are traveling a lot farther, and in general, it's also helped the economy. We've raised a lot of money. So even though we've been able to use new technology to decrease our emissions, we're still high on our energy consumption. So it's something we still need to work on. Also, part of the Clean Air Act, we came up with some new technology. The first new technology that we came up with is for smokestacks is wet scrubbers and electrostatic precipitators. So wet scrubbers, they actually go into your smokestacks and they actually remove the sulfur dioxide that is being released. So it actually traps it before it's released into the air. So that's pretty cool. So make sure that you read over this and also your particulate matter. Now, catalytic converters, these are always now required on cars, and it actually removes carbon monoxide and nitrogen dioxides. So historically, cars didn't used to have these catalytic converters, and then they made it required, so sometimes people had to have them installed in their cars, but now they are standard issue. And this has been a great help in terms of lowering our emissions from our transportation modes. We will stop here and continue in the next video.